Hey everybody, and welcome back to our HansenMATH online learning platform. I must say that the quality of work pouring in this week is looking very good. This video is going to be tailored to shoring up some of the issues that I'm finding, which quite frankly aren't many, and also showing you guys how to graph a hyperbola when you're giving what's called a general conic form, and we'll also look at writing the equation when given only the vertices and foci. So without further ado, let's get right into it and see what we're in for today. Today I'd like to start with kind of a walkthrough of what the totality of this assignment looks like. This PDF is called "This Ain't No Hyperbole." This is the real deal, folks. So what we're going to do is we're going to do number one, which this is the equation of a hyperbola, but it's in what's called general conic form, not the friendlier, necessary, I would say, standard form. So we're going to do this one as notes together. Number one, number two, and number three is going to be part of your assignment. On the second page, yeehaw! We're going to use this information of the vertices and the foci, and we're going to write the equation of a hyperbola. We'll do number four together, and then you will work on number five and number six at your own pace. And that is the totality of this assignment, which is called "This Ain't No Hyperbole." You can also think of it as the continuity learning plan lesson number 4. So without any further ado, here we go. First things first, how do I even know I'm looking at the equation of a hyperbola? Well, the tell here is that you look at your squared variables, the x squared and the y squared. One of them has to be the opposite sign. So since this y is +4 and the x squared is negative, this is a tip to me that this is a vertically oriented hyperbola because the positive one has to go first and the minus one has to go second so that it ultimately gets into the standard form. So let's work through this together. I've got my orange pen out in honor of my nice orange hoodie, and let's do it. All right. So the first step is to reorganize. So normally you'd start with the x stuff, but since this has the negative, that goes second. So what's ever positive, and I'm talking about your squared term, whatever is positive goes first. So since this is positive, the y squared, the y group goes first. So we'll reorganize this as follows. We have positive 4y squared. So I'm going to write that down. Now, what else do we have that's y? We have this guy, minus 24y, plus, I'm going to put the empty box. What we're going to do is complete the square. This is very similar to what we did with the ellipse, and we're trying to create a trinomial. So this is all of the y terms, if you will, or the y trinomial. Now we start arranging the x stuff. So we have this negative x squared. What else do we have that's x? Plus 2x, plus 2x, plus the empty box for the constant of the trinomial. Now we have our equal sign. We're going to take this positive 19 and we're going to subtract it to both sides. So we have 0 take away 19 is a negative 19. And then if we're going to dump a constant amount down in these two boxes here, we have to balance it out on side 2 of the equation like so. All right. Now, next step is we want to pull out the coefficient on the squared terms. Okay, that's the next step in completing the square. So we're going to pull out the coefficient here. The coefficient on y squared is 4, so we factor it out. So now we have our y squared. This is a minus sign, bring down the minus. If you divide 4 out of 24, you're left with 6, plus the empty box, close the parenthesis. That is your y trinomial. Now, this negative x squared, this is really like a -1, okay? So I picked this example on purpose so that you don't forget to factor out a -1 if it looks like this. You know, if it was a -6, you'd factor out -6, but since this is a -1, you pull out the -1, parentheses, x squared. Now, this is super important right here. Okay, now we're going to take it nice and slow but sure. You have to get back to a +2 here. Since we factored out a -1, to get back to a positive, you need another negative. So a -1 times a -2 is back to +2, right? So sometimes you got to slow down a little bit and double check. Does a -1 times a -2 get you back to +2? Yes, it does. Slap down the X and put our empty box, okay? Does everything look good so far? I think so. Equals -19 plus the 2 empty boxes on the right side of the equation. Okay, next step. How do you get the value of the number in the box, the constant number? Well, this is the same thing as we did with the ellipse, or prior to that, the circle. You take the coefficient here on the linear, just the plain y term, you cut it in half, and then you square it. Half of 6 is 3, and 3 squared is 9. Okay, again, you cut this in half. Half of 6 is 3, and then 3 squared is 9. But we have to balance it on the right side of the equation, okay? We just plop down a 9, but it's not really just 9. It's getting magnified by the 4 that we factored out. So we really have to put 4 times 9 on the right side of the equation. If we do not do that, it's not properly balanced. This was a mistake I saw some people making last week on the ellipse, which is one more reason why it is a good use of time to revisit. Okay? So the y parenthesis is all set. Now for the x parenthesis to get the trinomial, same thing here. You take half of the x coefficient, half of 2 is 1, and 1 squared is still 1. To balance it out, we have this 1 here, but it's being magnified by this -1. So to balance the equation, we have to multiply by -1, which is coming from here, times this 1. Like so. Okay. I'm going to erase just a tiny bit here just so it doesn't get too messy, and we will proceed. Okay. Got to get my pen back here. It ain't easy being a teacher, ladies and gentlemen. Okay. The next step is to convert to the perfect square binomial. So bring down your 4, which we factored out. Now, this trinomial, this is a perfect square trinomial, this y squared minus 6y plus 9. It's the exact same thing as y, and then you take half of this -6. Half of -6 is -3. I promise you, if you were to do y minus 3 times y minus 3 and FOIL it out, you'll get right back to this. These are synonymous, okay? Next, we bring down our -1 from here. And now we work on our x binomial square. So bring down your x, and again, take half of this guy. Half of a -2 is a -1. And now you're going to simplify on this side. We have a -19 plus 4 times 9 is 36, and -1 times 1 is a -1. So we have 19 plus 36 plus -1, which should be 16. Okay, how does everything look so far? Pretty good. The final touches here for the standard form of a hyperbola, you can't have anything other than 1 right here. So you divide out this 16 by itself to achieve 1. But since you do it here, you have to do it to everything on side 1 of the equation. Oh, that wasn't very good. Like so. Okay. That was a 16. Okay, now simplify a little bit. 4 divides into itself completely. 4 goes into 16. How many times, people? 4 times. Okay. On the x fraction, we have negative, well, we need this minus here as part of the equation. The 1 divides into itself, so that's going to go away, and 1 goes into 16 times. You leave it alone. This doesn't really simplify so much. And then the 16 divided by itself is 1. Okay, let's do a little rewrite to make it look nicer, and then we'll be well on our way. So that 4 canceled. So we've got y minus 3 squared over 4 minus that 1 canceled, or multiplying by 1 doesn't do anything, so it's kind of invisible. We have x minus 1 squared over 16 equals 1. Oh, hooray, we've got our standard form of the hyperbola. So now let's pull out some pertinent information, and we'll be in good shape here, my friends. The most important thing to start with, I would dare say, is the center. And the center is, ooh, don't be fooled. I know you want to look over here. If this was an x where I'm pointing at, you would start here, but x is over here now. It's in the second fraction. You've got to start here. All right, so you take the opposite of this minus 1, which is a positive 1, and on your y coordinate, the opposite of minus 3 is 3. Remember, because even though, you know, it's the textbook calls it HK, it's still XY. So the X coordinate goes first from here. The Y coordinate goes second from here. So let's plot that big, beautiful center. Over 1, up 3, bam, there is our center. What can we do next? Well, we need to work on the X box. Another thing that might be helpful to write down is, which way do we go, George? Which way does this hyperbola go? Since the y fraction is first, y means vertical. So it's going to be a vertical hyperbola, meaning it's going to look something like this. Okay? And so we'll do our square roots. The square root of 4 here is 2. It's on the y fraction. So we're going to go 2 up and 2 down. Okay, that if you connect it, that'll give you your transverse axis. The square root of 16 here is 4. That's on the x term. So x is sideways from the center. 1, 2, 3, 4. 1, 2, 3, 4. Okay, put in what I call the x box, like so. Okay, I got kindly bad drawing skills. And we'll put in the asymptotes, which help give the hyperbola its shape, its width, if you will. All right. And now to put the branches in, since it's vertical, I start at the top. I go towards the asymptotes, but I'm not supposed to crash into them. It just kind of fences it in, and the same thing there. All right, good enough for government work. All right, what can we do now? We can put in the foci. The foci are related by the equation c squared equals a squared plus b squared. Mr. Hansen, how do you remember it's plus? I remember that it's the opposite of the sign between the fractions. So since there's a minus between the fractions on the hyperbola, it's a plus for the foci equation. So let's see what we have here. We've got c squared equals a squared and b squared are the denominators, which are 4 and 16. So that's 4 plus 16. C squared equals 20. The square root. So c equals the square root of 20, which you could simplify as, 4 times 5? So that's 2 root 5. But to get a grasp about how far to go in the picture, I do want the decimal. So the square root of 20, which I think I remember, is about roughly approximate to 4.5. So since this is a vertically oriented hyperbola, I start at the center and I go 1, 2, 3, 4 in a pinch. That's one focal point. And then from the center, 1, 2, 3, 4, and a pinch. That's the other one. Now, what about the coordinates of the foci if you wanted those? Now, note that, you'll notice I'm not a big formula person, and that's how I can remember this year after year. I don't have to look up the formulas in the book because I remember how it works. So if you think about how we just put those foci points in, we started from the center and went up and down. Up and down is governed by your y coordinate, and it was from the center. So it's all about going back to the center point. We didn't do anything to the x value. Everything was still over 1 and then up or down. So we're going to stick with that 1 that was the x coordinate from the center. And then from that 3, you see, from that 3, we went up a distance of root 20 and down a distance of root 20. So I can just put plus or minus root 20, which is 2 root 5. In my opinion, that's a quick way to write out the coordinates of the foci, okay? To me, it's more important, think about what you're doing. You're starting from the center, which was 1, 3, so I plop that down. You still have your 1, 3, that's the x and the y from the center, but since you're going up and down, you add the plus or minus 2 root 5, which is the c value, to the y coordinates. If this was a horizontal hyperbola, you would have added that to the x coordinate. It's really as difficult and as easy as that. All right, next, we want the equation of the asymptotes. I think I can make that a little bit easier for you as well. How I like to do it is the following. It's always y minus the y coordinate from the center, which is 3, okay? Plus, or no, I'm sorry, equals. Now, is it a over b? Is it b over a? What is it? Well, quite frankly, I don't even have that memorized. What I do, and this always works no matter which way the hyperbola is oriented, go to your center here, okay, and count the rise and the run from the center to the corner of your x box. So this one is rise, 1, 2, run, 1, 2, 3, 4. So your slope here is 2/4. You see, forget about a over b or b over a. Who needs it? Think about slope from the center to the corner of the x box, rise over run, okay? Up to over 4. This method always works. Times x minus the x coordinate of the center, so it would be x minus 1. No formulas to remember. Simplify it just a little bit. So we've got y minus 3 equals 2/4 is 1/2 times x minus 1. And that does it. I could put, I really need a plus and minus in front of the slope because one asymptote is going up and the other is going down. And that's about it. Again, if you wanted to distribute this, you could get y equals mx plus b, blah, blah, blah. This is the gist of it. And the only thing else I want to add to this for you fine people is let's do the eccentricity real quick. A hyperbola has it as well as the ellipse. So the eccentricity is still E equals C over A. Same thing as the ellipse, E equals C over A, eccentricity. The C value for this guy was square root of 20, which was about 4.5. So we'll use square root of 20 over the A value was 2. So A squared was 4. So that implies A is 2. And we can simplify that using the old calculator. Let's see, the square root of 20 divided by 2 is 2.23. That is the eccentricity. How it works for hyperbolas is the following. The larger the number is, the more flattened out the branches are. The closer the number is to 1, the more pinched together or almost touching the branches are, okay? Narrow. So closer to 1, narrow, bigger number, flattened out. C over A, same deal as the ellipse. Okay, let me get you started on number 2, and then you will be on your own. For number 2, I'm just going to give you a little start here, and then you guys can take that one home, as well as number 3. So let's look at number 2 here. What are the coefficients on the x squared and the y squared terms? The x squared has a coefficient of 9. The y squared has a coefficient of -16. Whatever negative has to go second. So for this one, we're going to organize the x stuff first. Okay, the x stuff first, because on the x squared, this 9 is positive. The positive one goes for the first group. The minus one goes to the second group. So we have 9x squared. What other x stuff do we have? We've got a minus 18x. Okay, plus the placeholder box. Now we'll do the y stuff because of the minus on the y squared coefficient. Minus 16y squared. What else do we have? That's y. Minus 32y. 32y plus the empty box equals, take this minus 151, add it to both sides, so you get a positive 151 plus the 2 boxes to balance the equation. Okay, next, what are you going to do? You need to factor out this 9. So you're going to do 9, pull that out, x squared minus 8. Oh, no, not 18, right, folks? Because if you already divide out the 9, if you divide 9 out from 18, you're left with 2 plus the box minus, you got to factor out the 16, y squared. Now, here's why I'm doing this with you. Again, I don't want you to make the mistake. We factored out a -16. We have to get back to a negative here, so this sign is positive, because negative times positive is still negative. If you divide 16 out from 32, you're left with 2, like so. Okay? Again, take your time. Make sure it makes sense. Think about what you're doing. So we've got that. And then we have 151 plus the 2 equation balancers. Okay? I'm going to let you guys finish this one off. You'll notice that since the x grouping is first, this is going to be a horizontal hyperbola, so it's going to end up looking something like that. So I wish you guys some luck. You can hit pause now or whatever and finish off 2 and 3, or you can keep watching for side 2. Do this how you'd like. I'm going to hit pause right now to queue up side 2, and then we'll finish off this video. Okay, 4, 5, and 6 all work on the following premise. You are given the vertices and the foci of the hyperbola, but nothing else, and you're asked to write the equation. So really, to do this, you need the center and you need A and B, and you really, since we're dealing with foci, are going to need to employ C. So how I like to do this, since I'm a visual person, is I like to make a sketch, and it can be a really bad sketch like I just did where it's all cattywampus. And I'm going to put in the vertices. So the vertices are at -523, which is a little bit left and quite a lot up. So something like that. If I say this is -5 and that's 23, and then I'll put in the coordinates here. That is -523, okay? Does that make sense? Yep. That is one vertex. And the other one is at -5, -7. So that's also left, but then a little bit down. Yeah, I'll put it like right there. Okay, again, this doesn't need to be perfect. It just needs to be a rough facsimile so that you can figure out what's going on here. Now, the vertices tell you which way the thing is going. If you connect them, that is your transverse axis. So this, you can already see this is going up and down. So the branches ultimately are going to go like this and like that. So you know this is a vertical hyperbola, so the y fraction is going to have to go first. But before we get into any of that, we need to find the center. So the center visually is somewhere here, but how do we find its coordinate? Well, everything here is on this -5 line. Okay, it's going through -5 on the x-axis. So, this coordinate here of this vertex was -5, 23. This one here was -5, -7. So the center is still going to be -5 something. How do you get that something, or how do you get the y value? Well, it's a midpoint. So this y coordinate here, it's directly in the middle of 23 and -7. So how I do it is quite frankly, I just find the average. So I take this y coordinate, which is 23, plus the other y coordinate, which is -7, and I divide by 2. It's an average or a midpoint. So if you do that, you get 23 plus -7 is 16, divided by 2 is 8. So it's no longer a mystery, my friends. The center is -5, 8. Okay? Well, why is that useful? It's useful because it's of the utmost importance to write the equation. So again, since everything is arrayed vertically here, I know I have to have the y parenthesis first. The y coordinate was 8, so a -8 goes into the parenthesis squared over a denominator, that's going to be a squared when we get to it, minus the x parenthesis, that was x. The opposite of this -5 is +5 squared. It has to equal 1, and then I need my b squared denominator here. So now, how can we work on the denominator so we can finish this one up? Well, let's think about how the hyperbola works. If I can figure out the distance from the center to the vertex, that is always a. Center to vertex is always a. So think about it. I'm at a height of 8 here, and then I'm going up to a height of 23. So what's the difference from 8 to 23? If I can find that, that's the length of half of the transverse axis, which is a. Well, I'll subtract them. 23 take away 8 is 15. So now I know that a is 15. Okay, that is a fact, but you need to know 2 out of the 3 of the A, B, and C to get somewhere here. So now we'll use the other thing that we were given. We are given that the foci are at -5, 8 plus 5 root 10 and -5, 8 minus 5 root 10. Now, we have to work smarter, not harder. Our center is at -5, 8. If you're a good inspector, you'll notice that -5 and 8 are part of both of these foci coordinates, but in addition to the 8, you add 5 root 10 to the y value here, and you subtract 5 root 10 to the y value here. That's because in addition to the center, the focal points are going up and down. That's why they're on the y coordinates. This is the c value here, this 5 root 10, because it's 5 root 10 up and 5 root 10 down. So that was the giveaway of the c value. So c is 5 root 10. Okay, now what is b? We don't know, but we'll find it out because these guys are related by the equation c squared equals a squared plus b squared. Plug and chug. C squared, c is worth 5 root 10. So that's 5 root 10 squared equals a squared, a is 15, so it's 15 squared plus b squared, we don't know what that is. Okay, crunch it out. How do you do 5 root 10 squared? Well, 5 squared is 25. Root 10 squared is just 10. So 25 times 10 is 250. Okay, equals 15 squared is 225, and that gives you b squared. Next, Subtract 225 to both sides so that you can get b squared by itself. 250 minus 225 is 25. These cancel, bring down your b squared. And you might be tempted, like I am, to take the square root, but you don't have to, because b squared is your second denominator. So as soon as I get that, I can stop. B squared is 25. Okay, boom, put you in right there, 25. And a squared always goes at the bottom of the first fraction. Since a was 15, a squared is 15 squared. 15 squared is 225. So that is it. That is your equation in standard form of the hyperbola, given nothing more than the foci and the vertices. If I lost you somewhere here, you can rewind. Just be alert. You got to make this sketch, I really believe in, so that you can figure out, first of all, is the hyperbola going up and down with the y fraction first, or is everything moving sideways and the x fraction goes first? I hope this was helpful. I'm going to put number 5 and 6 into your capable hands. If you need help, please email me or consider coming to my office hours and we'll try to work through this. Thank you guys very much. Not only is it a great day to be a pioneer, it's a great day to be Mr. Hansen, because aside from my misspeaking and silliness, I have done this video in one take, no editing required. How cool is that? So good luck to you guys. Please keep up the good work. You're doing a great job. I know most people don't like this online format, but we're making lemonade out of lemons, and I sure do appreciate each and every one of you. Miss you guys. Take care. Be good. And I'll see you on Google Classroom. Have a great day.